So we're going to continue on our lessons about point and slope. And these examples will apply what we talked about previously in terms of calculating slope by looking at the graph. But if you notice in these examples, the scale of the x-axis and y-axis is a little bit different, so I want to make sure that we talk about these problems. So looking at this first example here, I'm going to pick 2 points again, so probably 2 that I can easily identify. So I'll take the origin, and let's say I'll take this point here. So now when we're considering rise over run, when we go up, we're going to go up 7, 14, because that's the scale that we're given. So our rise is 14, and then we run. When we run, we're also running 7. Okay, so this case, in this case here, 14 over 7, our slope denoted as m, which we'll talk about a little bit more in the next lesson, would be 2. Okay, so I know it kind of works out. Well, I guess it would be 2 over 2, which is 1. So just make sure when the graphs are given this way that you're looking at the scale. Okay, next example, pick 2 points. So we're going to go up 6 over 2 because that's the scale that we're given. So our slope in this case would be 3. And then for this next one, 2 points again, we're going to go up 8 over 2 because that's the scale that's given. So our slope would be 4. So unless a number is provided for you like here, just assume each tick mark on the graph is 1. Or if it gives it to you differently, you can use the scale. Still rise over 1, but just be careful. Like in this example, going up wasn't 1, it was 8. Okay, next, so we're going to continue on with talking about slope, but now we're going to be able to calculate slope from 2 points by hand. And so the formula for slope, given 2 ordered pairs, x1, y1, and x2, y2, those are just placeholders to mean 2 ordered pairs, we can calculate slope by doing the change in y, so y2 minus y1 over x2 minus x1, or you may have learned this as y1 minus y2 over x1 minus x2. Either way will work, you just have to be consistent with the way you're subtracting. So notice y2, x2, y1, x1. Okay, so those should line up however you subtract. So just subtract in the same order. So finding slope from a pair of points. So what we'll do is we'll calculate the slope formula, but we'll also see that you can do these on a graph as well. Okay, so in this case, we have x1, y1, x2, y2. So our slope formula we're going to subtract. So I'm going to subtract the first point minus the second point. So I would do 7 minus 4. Now when I go to do the y-coordinates, we have 6 minus negative 2. Notice I started from the first point minus the second, x minus the second x. Okay, so 7 minus 4 is 3, 6 minus negative 2, these become positive, would give us 8. So the slope here would be 3 over 8. Okay, so another way you could do this problem is you could plot the 2 points, so 6 comma 7, would be 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6, 7. So there's our first point. Our second point is negative 2 comma 4, negative 2, 1, 2, 3, 4. And so you could make a line out of these 2 points and then do rise over run to calculate the slope. So if you're more visual or if you like pictures a little bit better, this way would work as well. And next, find the slope from the 2 pair of points. So m is equal to, we're going to do change in y. So now I'm going to subtract going the other way just to show you the different forms this could come. Negative 3 minus 1 over 4 minus 2. And then you simplify. So 3 minus 1 is negative 4. 4 minus 2 is 2. So if you reduce, the slope would be negative 2. And again, you could plot the 2 points to determine that. Looking at this one here, 7, negative 2, and 7, comma 4. So we use our slope form, negative 2 minus 4 over 7 minus 7. And so the top is negative 6. When you divide by 0, that's when it's undefined. Okay, and I do want to draw this one so you can see the line. So 7, negative 2, 1, 2, 3, 4, 5, 6, 7, negative 2, and 7, 4. 1, 2, 3, 4. So these 2 points would make a line. And so in this case, the line is vertical, which means undefined slope. Example 4, find the slope from these two pair of points. Again, we're going to subtract -2 minus -2. This negative here comes from the formula, y1 minus y2 or y2 minus y1, however you think of it. So the minus in between those two values is built into the formula, and then -2 because the points are negative. And then we have 7 minus -4. So in this case, we'd have 0 over 11. And you can plug these values into your calculator. I would just make sure you do numerator divided, like get the numerator and then get the denominator and divide them. And we can see that this is, so 0 over any number is just 0. So in this case, the slope would be 0. And then, so let's plot the 2 points to take a look at this line. So -4, -2. So -4 on the x, down 2. And then 7, 2, 1, 2, 3, 4, 5, 6, 7, -2. And if we connect the 2 points, we have just a flat line. So one way to remember slope is picture you're walking along, you're taking a hike. As you're walking on flat land, you're really not putting any effort in. If you go to scale a mountain, you're going positive. If you go down the mountain, you're going negative. And then if you try to climb a vertical wall, it's undefined. You're going to fall unless you're in the matrix and you can do that. So this is a picture that some of my students have liked to use or remember to determine if slope is 0, you're walking on flat land, not a lot of effort. You're going up a mountain, positive, down a mountain, negative. And then if you try to scale a wall, it's not possible unless you have some superpower. So slope is also defined as a rate of change, and this is where we can get into some really cool examples and graphing some applications. But let's say we're riding our bike at a speed of 2 miles per hour. So I'm going to label, we have the x-axis, which is time, and the y-axis, which will be miles. Okay, so you start at 0, 0, but you're riding your bike at 2 miles per hour. So for every 2 miles, it's going to take 1 hour. So you're going 2 miles, your distance traveled on the y, over 1, because time or number of hours is 1 hour. Same thing, after another hour, you will have ridden 4 miles, because another hour has passed and you've gone 2 miles. So if we plot these points and keep going, notice that the slope is just 2 over 1, which is the same as 2 miles per hour. Okay, so you don't have to necessarily do something like this for a test or anything like that, but it helps to understand that slope is a rate of change, because when we get into the next application problem, that's exactly what we're going to be doing. So if a new car is valued at $24,600 and 8 years later it is valued at $3,000, then what is the average rate of change of its value during those 8 years? And so for this problem, they've put a graph here for us. Sorry, you might hear my dog playing with her food ball. That's the only way she stays semi-quiet in the morning. Okay, so they've graphed it for us. At 0 years, our car is $24,600. Okay, and the reason why that's at 0 years is just starting. That's the original value. No time has passed. And then cars do depreciate this way. They lose value quickly, and then it kind of evens out. And then after 8 years, the car is valued at $3,000. So the average rate of change is essentially if there were a line between these 2 points. And that's what this problem is asking us to calculate. Okay. So when we're doing this, there's a couple of things to note here. The y-axis is talking about dollars. So when we talk about our slope, it's going to be change in value. So our dollar amount over x, which is change in time. So we're going to end up, value is in dollars amounts and time is in years. That's what they've given to us in this problem. Okay, so again, slope as a rate of change, we're changing how many dollars or how much change in value over a certain time period. So from this problem, we can get 2 points. Our first point would be at 0 years, the car is $24,600. And at 8 years, so that would be our x value, the car is valued at $3,000. So in order to calculate slope here, change in value, so we have 3,000 minus 24,600 divided by 8 minus 0. So if we plug this into the calculator, we have 3,000 minus 24,600, which would give us negative 21,600 divided by 8. And so we would get negative 2,700. Okay, so the average rate of change is negative $2,700 per year. And notice that our fraction lined up with that as well. If you think back to unit conversions, it's kind of along the same idea here. Our change is dollars per year, so change in dollars would go in the numerator, and change in years would go in the denominator. If you have any questions, remember I'm available to help. Please feel free to reach out to me.